Imagine you buy a smartphone. At first, it only has basic features like calling facility, messaging, camera, or basic settings. Later, you install apps like WhatsApp, Instagram, or your banking application. Have you ever wondered why adding these new apps does not require changing the phone's operating system? How these are supported? The answer lies in a powerful architectural pattern called microkernel architecture. This is also known as plugin architecture. In this session, we will explore how microkernel architecture works, where it is used, and its advantages and disadvantages. Microkernel architecture is an architectural style, like other architecture styles, which we have already covered in other sessions, like layered architecture, modular monolithic architecture. Right? Now, microkernel architecture divides application into two parts. Application into two parts. One is a core system. Another is a plugin. Core system provides essential functionalities and plugin adds optional features without changing the core. This provides basic functionalities and this provides features, add-on features. The core remains stable while new capabilities can be added or removed independently without touching the core. Just think of it like a smartphone operating system. The operating system provides the essential services, while apps extend its functionalities without modifying operating system itself, right? Apps. This is OS, operating system, right? Now, um, take an example of any IDE, right? Or for simplicity, any code editor. So what basically it provides? When we install a code editor, it usually provides basic features such as you can open a file, you can save a file, or edit the text, right? These are the bare minimum core functionalities provided by an editor. Now, think that you want to support multiple programming languages. You want to write code using this code editor. So now you need features and functionalities related to, say, Java or Python, or you want to integrate your code editor with GitHub. Nowadays, the AI chatbot is integrated with the code editor, right? These are all the plugins. Instead of modifying the code editor, we simply install plugins, right? You have already done this. You install extensions and you start working, right? Each plugin adds a specific feature, while the core editor continues to operate the same way. If one plugin has an issue, you can disable or remove that plugin without affecting the basic editor. This is essentially the core of microkernel architecture. There are two parts, the core system plugin. Now, how it works. The user performs an action, right? In code editor, right? The user performs an action. The user tries to write the Java code. The request reaches the core system, right? Java code. It reaches the core system. The core checks whether the functionality belongs to itself or a plugin, right? If this is just a text modification, then it is supported by core system. So no need of plugin here. But Java code requires plugin to handle Java features. So now the core checks whether the feature is belongs to the core system or it is part of the plugin. If it's plugin feature, the core delegates the request to the appropriate plugin. Instead of handling by itself, it redirects the request to the plugin. The plugin performs required task and returns the result to the user. The core sends the request to plugin basically. Right? Now, this is applicable for all the features available. Now, again with Git integration, right? This is for Java. User writes the code. Now, he tries to commit this code to Git. Git. But first, the request is sent to the core. Does core has that functionality? No, because it only supports basic functions. Functions like file, edit, save, right? Now, what does core do? It will send this request back to the plugin. The Git plugin has that functionality. So, the plugin will handle the request, then send it to the Git. The code is committed to Git. The important point is that the core manages the overall system. Every time the request first goes to the core, then core decides whether I'm able to handle this particular request or I need to make use of available plugins. Now, why this architectural style is popular? It provides extensibility. New features can be added without changing the core application. That is clear, right? You can add as many features or plugins as you want. Easy maintenance. Each plugin can be developed, tested, and updated independently. This is very obvious. Now, Java plugin is independent of Python plugin and it is independent of Git integration plugin, right? They can be developed and tested independently and just can be attached to the core functionality. And it provides flexibility. User installs only the features they need. If you need only Java, you're good. No need to install other plugins. Better stability. Since the core changes less frequently, it tends to be more stable and reliable. Also, it provides faster feature deployments. Teams can build new plugins without impacting the core functionality. So these points make microkernel architecture ideal for products that need to support many optional features. Now, um, when one should not choose microkernel architecture, right? It increases complexity. How? Designing a robust plugin framework requires careful planning because the core has to support multiple plugins and the plugin itself has to be robust to handle all the requests, right? It increases complexity. Performance overhead. Communication between the core and plugins may introduce slight overhead. Every time there is a new request, the plugin talks to core system, the core redirects the request to plugin. This might introduce a slight communication overhead and dependency management. Different plugins may depend on different versions of shared libraries, making compatibility more challenging because some plugins may run on version 1.1. Some may need version 1.2 or 3. So the core system always needs to be kept updated. Right? So, in real world examples, we have already seen um, the smartphone operating system, the core editors and IDEs, or content management systems, browser extensions, right? Or enterprise softwares with optional modules. These are all the places the microkernel architecture is commonly used. Whenever an application needs to be easily extended without modifying its core, the microkernel architecture is a strong choice. So, in nutshell, microkernel architecture separates an application into stable core system and independent plugin system. It makes it easier to add new features, maintain the application, keep the core stable over long period of time. However, it should be kept in mind that it introduces complexity and communication overhead. Thank you for your valuable time. This session is part of Software Architecture series. There are more topics covered in different sessions. Please take a look and we will see you in next session. Thank you.